Okay, so we're going to try this again. Second skill from section 5.6. So we're going to change from standard form. So remember, this means some number times x plus some number times y equals some other number, call it c. And we usually said that we wanted a, b, and c to be integers, but technically it really doesn't matter. But strictly speaking, standard form a, b, and c should be nice numbers, no fractions or decimals or weirdness. And our goal here is we want to turn this into slope-intercept form. Now, why would we want to do something like that? Well, if you haven't viewed the video yet on how to graph using slope-intercept, you may want to do that at this point. This is really, excuse me, this is really the reason why we want to do that, is because often we want to be able to get a picture of our line, in other words, a graph. And usually the most efficient and easiest way to do that, rather than plotting a whole bunch of points, which is what we did before, is to put it in this slope-intercept form. So remember, that was y equals some number, call it m, times x, plus some other number, call it b. So here the m was our slope and the b was our y-intercept. So we've actually done this in the reverse form before on your last unit test before break. So now we're just going the other way. I'm giving you the standard form, we're moving into slope-intercept form. So our goal here is that we want to take things that look like this, so 6x plus 3y equals 12, and turn that into y equals negative 2x plus 4. These are both equations for lines, and even though they look very different, they're actually the same equation, and you can move back and forth. The advantage of the slope-intercept form is it's just, again, much easier to graph, because we can identify the y-intercept first, the b, where we begin, at plus 4, and then move from that point, negative 2, down 2, and right 1, because remember, we can think of that as over 1. So that's really the reason why we want to do this transformation. Now, so let's see how to do that. So I'm trying to turn 6x plus 3y equals 12 into y equals negative 2x plus 4. Well, if you see, well, all we're really doing here is solving for y. So we're going to play a little game here. When that game is called, if you can do this, you can do that. So if you can solve this problem, so 6 plus 3y equals 12. If you can solve that, you can solve this. You may have to do another step or two, but it's really not that much more difficult. So here, this is an old equation. We would have said, oh, I'm trying to solve for y. So I got two things that are happening. I'm multiplying by 3 and adding 6. I have to do things in the reverse order of what they're happening to y. So if I'm multiplying and then adding, I need to undo that by subtracting first. So we'll do the same thing here, but now I'm not going to subtract just 6, I'm going to subtract 6x. So on both problems, these eliminate. We bring down the 3y. This is a plus sign, so I don't need to rewrite it. So I'll just write it as 3y. Now on this side, these are not like terms, so this is one of the differences between the two methods, but I can even make it look pretty similar here, and I'll show you how. So I'm going to write this as 12 minus 6x. Okay, now on this side, I'm going to have 3y equals, I'm not even going to do subtraction because I don't really care what 12 minus 6 is. Now, first thing I want to do here is recognize that this isn't really slope-intercept form. Notice I have a number, and then the variable part over here, and then I have another problem. I still have this 3 here, so there's a few things I have to take care of. So the first thing I'm going to do is just rearrange this right-hand side. Remember, this is a positive 12, so I can rewrite the right-hand side using what's called the commutative property as negative 6x plus 12. And now I need to isolate y. So that really didn't have an analogous step over here, but I can even do it. This is a plus 12, so how about negative 6 plus 12? That's still the same. So over here, we would divide by 3, so I'm going to do the same. Notice I'm dividing the entire right-hand side by 3. So I'll get y equals, because remember those will divide and give me 1. So here I get y equals. Now, negative 6 plus 12 divided by 3. The way that I'm going to do this is by making both of those numbers be divided by 12. And look, it makes a little heart because we love math. So this is negative 6 over 3 plus 12 over 3. I'm going to do that here. So negative 6x over 3 plus 12 over 3. Now fractions, whenever I can, I'm going to simplify them, and I can here. So this would be y equals negative 2x plus 4, and this would be y equals negative 2 plus 4. Which of course we would never leave in the past, we would just add these numbers, but over here they're not like terms. So you can see that this was an old problem, but you can see how it relates to stuff that we're doing now. So remember the goal here, standard form, change to slope-intercept form. Why? Because this is easy to graph. Watch how quickly I can do this. So I'm going to slide this up. You're going to lose a little bit of what you can see. And to graph it, this is x, this is y. Begin at 4. Move negative 2 over 1. So down to right 1. That's 1, that's 4. Connect. And notice how quickly I had my line. And that's why this is such an easy way to graph. Begin at 4, identify your slope, down to right 1, and we've got it. So there is my slope-intercept form. This was standard form.